I was born in Egypt in 1943 and did my primary, secondary, and university education there, graduating from Cairo University with a bachelor degree in electrical engineering in 1964. Came to Canada in 1966 and did my graduate degrees here at the University of Toronto, graduating with a doctorate in 1969. I had a great career. I became a professor in 1969 and I still am, although I am officially retired. I had a tremendous number of leadership positions. I was fortunate to have had this opportunity. I was the chair of electrical computer engineering at the University of Toronto for 7 years. I was the vice president academic and provost of the University of Toronto for 9 years, and I was the dean of the faculty of engineering at the University of Waterloo for another 9 years. In terms of teaching, which is, I have to admit, is my first love, and the things that I'm still doing and want to continue to do for a while longer. Probably the greatest award I got there was Education Medal of the IEEE in 1996. And up till now, I think probably true that I am the only Canadian working in Canada who has been awarded this prestigious medal. In terms of my work as a researcher and my work with my graduate students and mentorship, I became a fellow of the IEEE, I became a fellow of the Royal Society of Canada, a fellow of the Canadian Academy of Engineering, and I think all of these probably are in recognition of that. The third aspect of what we do is administration and leadership, and here again I had tremendous opportunities, and I believe I made some contributions, and again handsomely rewarded, so I'm a happy person. I received 6 honorary doctorates recognizing my contributions to higher education.
When Adel moved to Waterloo, it was important to him to start teaching again, and I think that was wonderful for the students. One really hears about how he just captures their attention when he's teaching, when he's in front of a classroom. And I remember when I first saw him in person, of course I had studied out of his textbook, and so I knew the name, and I saw him at a gathering at Convocation Hall in the fall of 1995, where as provost of the University of Toronto, he was introducing 4 Nobel Prize laureates. And again, he totally captured my attention. And it's not just how he deals with large groups of people. When you deal with him one-on-one, you really get the impression that you have his total attention and that you're the most important person in the room.
Even in high school, I recall my classmates kind of gathering around me and asking me to explain some of the things we learned. So I had to dig deeper to understand these subjects in order to be able to explain it to them. And then the idea of teaching was born. My philosophy is to provide the students with more than what they can get by reading a textbook. There has to be a reason to come to class, a lot more than getting course notes or just going over the same materials that they can more efficiently and probably easier for them to read in a textbook. So my lectures, and I'm fortunate to teach in an area that I am passionate about, which is microelectronics. And my lectures tend to give the students how to think about a problem. I develop the material with them right on the board, And the main point there is, given a big circuit that you want to design or you want to analyze, how do you approach it? Where do you start? How do you think about the problem, etc., which is kind of the dynamics of the classroom that's kind of hard to duplicate in a textbook. I think the students recognize that I'm there to help them. I'm very transparent about what I'm doing there, and I'm there to assist them to learn the material. I think they appreciate I am very disciplined personally, and I'm always there on time in the classroom. And in return, I demand from them that if they want to come to class, and I don't take attendance, but if they want to come to class, and I'm always, of course, happy to see them in class, that they are coming there to listen to me and to engage with me. They are welcome to ask questions, they are welcome to answer questions that I ask, etc. But what I don't like and it's find it disturbing is when they engage in talking to each other and socializing. So we try to minimize that. But I think the students appreciate the fact that I am working so hard, and I think they also get some of the passion that I have able to transmit. I hope some of the passion that I have for the subject and for teaching in general. I don't take notes with me in class, or I don't take my book or a book in the classroom, and I develop the material with the students. I walk in the classroom with a piece of chalk, or these days with colored pens for the whiteboard, and I develop the material with them on the board. No slides, no transparencies, none of that. I feel that that's kind of an old-fashioned way of teaching, perhaps, but I feel that the students then are able to see how I'm doing it and learn from it. Now, how do I do it personally? It appears to them to be entirely spontaneous, but it's not. It's not. It is, I don't just walk in the classroom and talk about what I think is worth talking about. Before coming to class, I prepare. And I spend at least 1 hour per each hour of teaching in material. By the way, this is materials that I have written about and know very well, I believe, over the years, but I still have to plan the lecture. I leave some of the lecture a little spontaneous. So the students might ask a question, might take us in a little, might digress a bit, take us a little different direction, but by and large, the scenario for the lecture is all planned and worked out before entering the classroom. There is a wide variety of students in the classroom, wide variety of backgrounds, and which makes it a little difficult. I try to aim my lectures at kind of the average student, if you wish, although some students might think that it's that I'm aiming a little higher than this. Over the years, I have kind of developed a sense of where the students, how much they know, where they are, etc. And I try to, I don't claim that I have an absolute standard of where I'm aiming the students. No question, I'm affected by the class environment and by the makeup of the class, but there is a bit of a standard there that has been developed through experience of teaching over a long period of time. I try to gauge how much they understand and whether they are following by asking them questions throughout the lecture, and by trying to engage them in the lecture as much as possible. And of course, we have tutorials. Every week we have a tutorial, and I am there in most of these tutorials together with the teaching assistants, and then we assign problems that are directly related to the material we covered in the lecture, so I'm able to gauge whether in fact the students are moving along and grasping the materials that I'm teaching. I teach in essence to understand, and in fact a professor long time ago when I was an undergraduate student told me something that's become now a well-known saying. He said, if you want to learn a subject, teaching, and how true this is. But I want to expand it a bit and say, if you want to learn a subject, write about it. And in fact, so I claim that I write also to understand. When I started writing this book and I started in teaching this material, of course material has evolved over the years, that changed with the technology advancement, but I started teaching electronic circuits in 1969. First edition of this book came in '82. Why did I write the book? Because certainly at that time we had a different approach to teaching circuit design, and the books that existed at the time were completely different and inadequate, in my view, to the teaching of the subject. They were all kind of device-oriented book as opposed to circuit design oriented, and they were not highly analytical for the course that I teach. So the book, first edition appeared in '82, seventh edition appeared just this last fall. And in between, more than 32 years of technology advancement. The book helped me tremendously, and still does, in understanding electronics and understanding the material. In fact, every edition I bring out helps me some more in understanding the material, and then teaching the material in the classroom is another way for me to understand the material even in greater depth.
His textbook is really one of the great textbooks. I certainly remember having taken the courses in my undergraduate training that used the book. I learned out of the third edition, and everyone, or many people I talked to will know which edition they learned out of. So now, of course, we're up to the seventh edition. The first time I taught one of the courses that uses textbook here in Waterloo, I was using the sixth edition, and now seventh edition. When I go to conferences around the world, people still talk about that textbook. And let's face it, how many people remember which textbook they used in an undergrad course 15 to 20 years ago? So this is really unusual to see this, and not just people who graduated from Waterloo or Toronto, but really people from around the world. I recently hosted a conference in Waterloo, and there was a professor from India who came here and hadn't realized ahead of time that this is the university where Professor Sedra was working, and he said, "Oh my goodness, you know Adel Sedra and you know Casey Smith." And I'm like, yes, I know both very well. And he was, it meant so much to him to be here in Waterloo and to have a connection to the textbook, because that was the textbook he was teaching out of in his home country.
In terms of organizing the course, I think the organizing principle for me, and I'm kind of fortunate because I teach a subject that is a practical aspect. I teach analog circuit design basically at various levels, and I organize my teaching and my lectures around the object that we want to design. So maybe that we want to design an integrated circuit amplifier with wideband or such and such specifications, and then we start then talking about the various elements or various topics that go into making this kind of amplifier that meets the specs. And obviously we digress, deliberately digress, to study these various aspects, but always towards a certain objective, which kind of tries to emulate what students will face, engineers will face when they go out to work. It's learning, in a sense, is obviously learning is good for its own sake, but for engineers, learning it's always important for learning to have an objective, and the objective can be learning about designing something or another. I try to have the students focus on the overall picture, focus on trying to get the answer relatively quickly, not through too many equations and too many manipulations. Equations are important, etc., but it's also important for them to see the overall picture and to focus on the essence of the problem rather than on writing n equations for n unknowns and solving them. That, of course, can be done by anybody, but a good design engineer is one who is able to go beyond the writing of equations and the solving of equations.
He has found a way to make microelectronic circuits accessible to a wide body of learners from different disciplines. In my view, if you read the textbook, this is because of a very procedural way of explaining how things work with deep insight and in a way that sticks with students in the long run.
In my view, the fundamental aspects of teaching is motivated students who want to learn, the availability of these students, motivated students who want to learn, and motivated teachers who want to teach. And that is the two basic ingredients that make for good teaching and good learning on the part of the students. And this has not changed over all these years. Right. Throughout my career, and especially in the leadership positions that I was privileged to occupy, I have faced this challenge of teaching versus research, and with some who put them one against the other. I preached always and believed in, first of all, and tried to propagate the belief that teaching and research are integral, they are two sides of the same coin, and that they help each other. And to younger colleagues who are facing this tremendous pressure, I have to admit that the pressure to do more research and get research grants and publish, etc., has accelerated and increased over the years. And I regret a bit of that as a member of the academy. However, to my younger colleagues, I want to tell them that teaching and research are integral to one another. In fact, the best among us is the one who's able to have these two aspects of what we do reinforce each other, as opposed to get in the way of each other. My teaching has helped my research, and my research certainly has helped my teaching throughout the years. Teaching is a tremendously rewarding activity, and the reward comes not just in awards that one wins and all that kind of stuff, but the satisfaction that one has after giving a good lecture and seeing the students appreciate what one has talked about, and that it has kind of provided them with answers that they wondered about before. They might have seen something in their work environment before that they wondered about how it works, and then here we are explaining to them how it works and seeing kind of the students' eyes brighten. That's a great satisfaction to the professor as he or she walks out the classroom.
He's been a great mentor for me. When I go back to my graduate student days in Toronto, of course, he was provost, so I didn't get to know him very well at that time. I really just remember meeting him this one time at a banquet in San Francisco, and I spoke with him for, shall we say, the better part of 2 or 3 minutes. Many years later, when I was a faculty member in Alberta, he did a site visit where he was basically evaluating our programs. And I was introduced to him, and clearly he remembered having met me at that banquet. And of course I was a bit shocked, but when you talk to other people, they seem to have that same experience of him. I mean, he will remember meeting people years later and what the conversation was about and what your interests were. So he's really been a great mentor to me since then. I really am not afraid to discuss topics about how to teach materials, how to even in my role as associate chair undergrad, how to evolve our programs and what how we should be teaching various aspects of circuits, but also of electrical and computer engineering. Often when we look at faculty colleagues, we'll see they're people who are great teachers, people who have great research accomplishments, or people who have made great contributions to university governance. And it's not often, I mean, it does happen, but it's not often that we see people who are passionate about each of these and have made great contributions in each domain. And then when I think of Adel, and I think of Adel as a role model, I think that's something he has done very well, and that I would certainly like to emulate in my own practice.